Welcome back to the deep dive. Today we're not just talking about what is on your dinner plate. We are really talking about the fundamental machinery of life itself.
Yeah, it's a pretty massive topic.
Because if you really stop to think about it, and I mean really zoom in on this, every single cell in your body right now, every strand of hair, every enzyme that's firing in your brain while you listen to this, it is all made out of something you once ate. You are quite literally a walking, talking collection of metabolized groceries.
It is a really humbling thought, isn't it? We tend to think of food just as fuel, like gas in a car.
Right.
But you don't turn into gasoline. With food, you actually become the material.
Exactly. And to kick things off properly today, I want to go back way back. I'm going to throw a little Sanskrit at you.
Oh, starting with the classics. I like it. I'm ready.
The phrase from our source text today is anina jatani javanti.
Anina jatani javanti. That is, wow, that's a really profound place to start. It translates roughly to food gives life to living beings.
Yeah.
But in the context of the text we're unpacking today, it's not just some poetic statement. It's a hard biological assertion.
It sounds super simple on the surface. We eat, we survive. But the material we are diving into today, which is this fascinating, almost encyclopedic guide on mindful eating and the actual science of food, it takes that simple idea and just explodes it
It really does.
into a million fascinating little details. It challenges us to look at our plates and ask specific, almost uncomfortable questions. Not just, is this tasty, but what is the molecular purpose of this thing?
Yeah, and what is the history of the soil that grew this?
Yes. And that is the key distinction here. We are moving from just passively eating to mindful eating.
Which is so needed. The source material actually opens with a definition of a healthy person that I think most people today have completely forgotten about. It really challenges the modern medical definition.
I flagged that exact part too. Because usually if you ask someone, hey, are you healthy? They just run a quick diagnostic.
All right, do I have a fever?
No. Do I have a cough? No. Okay, I must be healthy.
Exactly. We define health purely as the absence of disease. It is a negative definition.
Yeah.
But the ancient wisdom cited in the text argues that health is active. It says a healthy person is one who eats food that is wholesome, sure, but also, and this is the kicker, in moderate quantities and appropriate for the season, the time, and the place.
That place part is what really stuck with me. It is not just about counting calories, it is about context.
Context is everything.
Like eating a heavy, heat-generating meal in the middle of a scorching summer in a tropical zone is, by this definition, unhealthy, even if the food itself is technically nutritious.
Precisely. It's about your alignment with your environment.
So here is our mission for you, the listener, on this deep dive. We are going to unpack the geography of flavor, why the soil in Punjab creates a different human physiology than the soil in Manipur.
And we're going to look at the evolution of the kitchen itself, going from ancient stone tools all the way to the modern gas stove.
And we are definitely going to get into the hard chemistry. We have to talk about the hidden hunger of deficiency, the energy equation of fats and carbs, and my favorite part, we are going to act as food detectives.
Oh, the lab tests.
Yes.
Oh.
We are going to explain the actual chemical reactions at a molecular level that tell you exactly what is hiding in your food.
It is going to be a journey from the dirt to the cell.
So let's get started with the map. Because when I look at a map of India, usually I just see political borders, right? States, cities.
Right.
But after reading the source material, I am genuinely starting to see a menu.
That is a beautifully accurate way to put it. It's a menu determined by the geology of the Earth itself.
Let's unpack this regional variety. The text highlights this incredible diversity in food habits across the country. And it makes this really strong point that this isn't just random chance.
No, not at all.
It's not like someone in the South just woke up and decided, hey, I think I like rice better, and someone in the North said, I prefer wheat.
Right, it's not a Yelp review.
It's survival.
It is entirely dictated by agriculture, which in turn is dictated by the soil and the climate. If we pull back and connect this to the bigger picture, culinary tradition is actually an intense adaptation strategy. You eat what you can grow.
And what you can grow depends on the rainfall and the literal mineral content of the dirt in your backyard.
Exactly. So let's look at the specific examples the source gives. Let's head north first, Punjab.
The land of 5 rivers.
And the land of heavy, hearty food. The text lists maize and wheat as the absolute, undeniable staples there.
And the dishes are iconic. Makki di roti sarson da saag.
Total classics. But let's look at the why behind them. Why wheat? Well, Punjab sits right on the Indo-Gangetic plain. It has this incredibly rich alluvial soil, packed with minerals, and historically, it has had abundant access to irrigation from those 5 rivers.
So it's basically heaven for wheat and maize.
Perfect for it.
Huh.
But there is a physiological component to this diet, too.
Right. The text mentions the labor aspect of the culture.
Yes, exactly. Traditionally, this is an agrarian society engaged in intense, back-breaking physical labor. We're talking plowing fields, harvesting manually, working from dawn till dusk.
You burn a lot of fuel doing that.
Massive amounts. And wheat provides a dense, sustained energy release. It is a complex carbohydrate that fuels those incredibly long days.
And then you have the dairy,
Hmm.
lassi, and just huge, generous amounts of ghee.
Oh yeah, the lipid profile of the traditional Punjabi diet is massive. And again, this isn't just because it tastes good. In the winter, Punjab gets cold.
Like really cold, near freezing sometimes.
And fat lipids are a high-density fuel for thermoregulation. You physically need that ghee to keep your body warm. If you ate a light, water-heavy diet in a Punjabi winter while working outside, you'd freeze. Your body wouldn't be able to keep up.
Okay, so that is the north. Now let's take a flight down south to Karnataka. The plate changes completely, the rotis disappear, the wheat vanishes. Suddenly, what do we have?
You have rice, and you have ragi.
Raji is so interesting to me because it's a millet. The text mentions Raji mudda, these dense, nutritional balls of finger millet.
Ragi is fascinating from an agricultural standpoint because it is incredibly hardy. It grows in the drier regions of the Deccan Plateau where wheat would completely struggle without massive modern irrigation. It is a drought-resistant crop.
So the culture adapted to the crop that wouldn't fail them when the rains didn't come?
Precisely.
Yeah.
And then there's the coconut. I mean, if you've been to the coast in Karnataka or Kerala,
Yeah.
you know you literally can't look up without seeing a coconut tree.
It's everywhere.
And it creates a completely different flavor profile and a totally different kind of fat source.
Yeah.
Instead of relying purely on animal fat like ghee, you have these rich, saturated plant fats from coconut oil. And notice the primary dishes mentioned, idli, dosa.
Right.
These are fermented foods.
That's a really good point. Fermentation is huge in the South.
It is essential. In a hot, very humid climate, food spoils incredibly fast. Fermentation is a brilliant way to control the bacteria. You intentionally cultivate the good bacteria to keep the bad, dangerous ones out.
It's a preservation technique.
Exactly. Plus, it makes the nutrients in the rice and the dal much more bioavailable. Your body can absorb them easier. It is gut health science, centuries before we even knew what a microbiome was.
That is amazing. Now let's look east. The text mentions Manipur. This was super fascinating to me because the palette shifts entirely again. It is not wheat, it's not ragi, it is rice, yes, but the accompaniments are totally different, bamboo and soya beans.
Bamboo shoots are a massive part of the cuisine in the Northeast.
And the specific dishes the text mentions aromba, which is a type of chutney, and sinju.
Aromba is a really great example of nutritional ingenuity. It usually involves fermented fish. Now, think about why you would ferment fish.
To make it last.
Right. The Northeast has heavy, relentless monsoons. Being able to preserve protein like fish through fermentation ensures you have a vital protein source year-round, even when the weather makes fishing impossible.
And the text points out soybeans as another major protein source there.
Which is distinctly different from the other regions. In Punjab, your protein is largely coming from dairy and wheat gluten. In Manipur, you are leaning heavily on plant-based proteins like soy. It is a completely different biological pathway to achieve the exact same goal, bodily growth and repair.
So what does this all mean for us? It means that Indian food isn't just one monolith. It is a collection of hyperlocal solutions to the fundamental question of human survival.
Exactly. We see diversity in the food because there is diversity in the soil and the sky. It's a direct, unbreakable link. But, it is not just what we eat that has evolved over time. It is how we prepare it.
Oh, I loved this section, the evolution of the kitchen. It is like a mini time travel documentary hidden inside the text. Because we take so much for granted now. I walk into my kitchen, I turn a little knob, and click, click, whoosh, I have instant blue fire.
The modern gas stove, it is clean, it is instant, and it's highly directed heat.
But the text takes us back to the chula, the traditional stove.
The chula, yeah. For listeners who might not be familiar, this is often an earthen, U-shaped stove, traditionally fueled by wood, charcoal, or cow dung cakes.
And the text implies this was a much harder way of life.
It absolutely was.
Yeah.
Think about the smoke alone. Indoor air pollution from biomass burning is a huge respiratory health issue.
Right.
And the chula required constant, vigilant tending. You had to physically blow on it, feed it fuel, manage the ash. It was a very active, demanding relationship with fire.
But I wonder, and the text doesn't explicitly confirm this, but I'm really curious, do we lose something in the flavor? I feel like Dow cooked over a slow wood fire just tastes deeper than Dow cooked on a modern gas ring.
Oh, you absolutely do. It is all about the thermal profile. A chula provides radiant ambient heat. It cooks slowly and surrounds the pot. A gas flame is high intensity, very focused heat on the bottom of the pan. Gas is efficient, sure, but it doesn't break down the starches and proteins in the same slow, gentle way.
So the texture changes.
Yes. Plus, with the chula, you get that smoky infusion directly into the food.
So we basically traded flavor and autonomy for convenience and better lung health.
And we traded independence. That is a really big one to consider. With a chula, if you have access to a tree or a cow, you have your fuel. You are self-sufficient. With a gas stove, you are tethered to a pipeline or a cylinder delivery truck. You suddenly become part of a massive global industrial supply chain.
That is a really cool way to look at it. The gas stove is a symbol of modern connectedness, but also complete dependence.
Exactly.
And speaking of labor, the grinding, the text mentions the shift from the silbata to the electrical grinder.
This is the one that really resonates if you've ever actually tried to do it the old way. The silbata is a flat stone slab and a cylindrical stone roller. You use your own muscle power, your triceps, your shoulders, your core to manually crush spices and lentils.
It is a serious workout.
It really is. But again, there is a fundamental chemical difference in the result. Using the silbata is a cold process. You are mechanically crushing the spices without generating any significant heat.
And the electric grinder.
Those metal blades spin at thousands of RPM. They generate intense friction and immediate heat. That heat can actually volatilize, meaning burn off some of the most delicate essential oils and spices like cardamom, coriander, or cloves.
Oh, wow.
So the grinding revolution gave us hours of our time back, but we might actually be losing some of the most subtle top notes of the flavor profile.
So the source text raises an interesting point about why all these changes happened. It lists technological development, obviously, but it also explicitly mentions improved transportation and communication.
Right. Transportation changes everything about a diet.
Oh.
Because now you can ship heavy gas cylinders to remote villages. You can truck in electric motors for grinders. And communication, the rapid sharing of ideas and recipes, means that a kitchen in Bangalore starts to look very, very similar to a kitchen in Delhi. We are seeing a massive standardization of the culinary toolkit.
Which is efficient, but maybe a little sad.
It's a trade-off.
So we have the geography mapped out, and we have the history of the kitchen. Now, I want to get into the engine room. The biology.
The energy equation.
Right. The text poses this really specific question. Why do marathon runners drink glucose water?
It is a classic physiology example. When you are running a marathon, you are burning fuel at an absolutely massive rate. Your muscles are practically screaming for ATP adenosine triphosphate, which is the actual energy currency of your cells.
And you don't have time to stop, eat a sandwich, and wait 4 hours for your stomach to digest it.
Exactly. Digestion is a very slow process.
Yeah.
And it ironically takes energy to get energy out of complex food. But glucose is the biological cheat code.
How so?
It is the simplest possible form of carbohydrate. It doesn't need to be broken down by the stomach. It just passes right through the stomach lining and goes straight into the bloodstream.
It's basically a nitro boost for the body.
It provides true instant energy. That is why runners take those little gel packs during a race. It is just pure, unadulterated glucose.
So carbohydrates are the body's primary go-to fuel source. The text lists the heavy hitters we all know: wheat, rice, maize, potatoes.
And sweet sources, too. Fruits like mango and banana, even common table sugar. These are all delivering that essential glucose payload. They're just packaged differently with varying amounts of fiber and water.
But then the text pivots to a completely different kind of energy, and it uses a very cozy seasonal example, the winter laddu.
The winter laddu.
Why do we eat them in winter? I always just assumed it was because they taste amazing and it's usually the holiday season. But the text says there is a deep biological imperative at play here.
There absolutely is. Let's look at the core ingredients mentioned in the text. The sand, the flour, sure, that's your carb base. But what really drives the laddu? Ghee, nuts, seeds.
Heavy, rich stuff.
Fats. Ghee and oils are lipids, and fats are highly concentrated energy. Just to give you the math, a gram of carbohydrate gives your body about 4 calories of energy. A gram of fat gives you 9.
Wow.
It is more than double the energy density.
And the text explicitly says this keeps the body warm.
Yes, metabolizing that fat generates internal heat. In the cold winter months, your body has to work so much harder just to maintain its baseline internal temperature of 37 degrees Celsius. Eating a ladoo rich in ghee and nuts is exactly like throwing a dense, slow-burning log onto a fire. It provides a sustained, long-lasting energy release that keeps your core warm for hours.
I love that. It totally validates my winter Ladoo habit. It is not an indulgence. It is critical thermal regulation.
Well, to an extent, you still have to burn it off.
Fair enough.
But the source uses an even more extreme example in nature to explain this concept of fat as stored energy, the polar bear.
Yes. This was such a surprising fact to find in a text primarily about human food and diet.
It is the ultimate example of the energy bank concept. Polar bears accumulate a massive, thick layer of blubber, which is just fat under their skin. Why? Because they go into hibernation. Or, even when they are active, they are constantly swimming in literally freezing water.
So during hibernation, they're just living entirely off the battery pack of fat they stored up during the hunting season.
Exactly. They sleep for months. They don't eat a single thing. Their body just slowly, methodically breaks down that fat layer to keep their heart beating and their lungs breathing. Fat is essentially a biological savings account for energy.
Okay, so we have carbs for the sprint, that's your checking account, ready to spend, and fats for the hibernation, your savings account.
That is a perfect analogy. Instant versus stored.
And the text gives us a nice practical list of sources for fats, distinguishing between plant and animal origins.
Right. Animal sources are the obvious ones. Butter, ghee, milk, meat. But the plant sources are incredibly crucial too. Ground nuts, sunflower seeds, coconuts, even tree nuts like almonds and walnuts.
Okay, so we have the fuel, but a body can't just be pure energy burning all the time. We need physical structure. We need to actually build the house.
Enter the proteins.
The text calls them the bodybuilding foods.
And it is a very accurate term. If carbs are the electricity running through the walls of the house, protein is the brick and the mortar itself.
The text mentions specifically that growing children and sports persons need significantly more protein. Why those two groups specifically?
It comes down to a physiological concept called nitrogen balance. Unlike fats and carbs, which are mostly carbon, hydrogen, and oxygen, proteins contain nitrogen. You absolutely need nitrogen to synthesize amino acids, which are the fundamental building blocks of your DNA and your muscle fibers.
Okay, so a kid is quite literally building new territory in their body.
Exactly.
Yeah.
A child is actively manufacturing new bone, new skin, new organ tissue every single day. They're in a massive construction phase. Adults are mostly just in a maintenance phase. And sports persons, when they exercise heavily, they are actually creating micro tears in their muscle fibers. They need that extra protein to repair that damage, making the muscle thicker and stronger than it was before.
Now, we all know the usual suspects when we think of protein: milk, eggs, chicken, fish. But there was one source mentioned in the text that I feel constantly gets overlooked in these discussions.
Which one caught your eye?
Mushrooms.
Ah, yes. The fungal kingdom makes an appearance.
The text specifically points them out. They grow in dark, moist places, and they are highlighted as a key source of protein, especially for vegetarians who might want some textural variety.
It is a really great call out by the authors. Mushrooms are fascinating because they aren't plants, biologically speaking. Their cell walls aren't made of cellulose like a vegetable. They are made of chitin.
Chitin.
Yeah, it's the exact same complex carbohydrate that makes up the exoskeletons of insects and crabs.
That is wild.
It is. And because of that, they offer a completely unique nutrient profile that sort of bridges the gap between vegetable and meat textures. They are a fantastic inclusion.
And for the strict plant eaters, the text lists pulses like moon and tuar dal kidney beans and soya beans.
Soybean is actually one of the absolute best plant-based proteins in terms of pure quality. It is what nutritionists call a complete protein,
Meaning it has everything.
meaning it contains all 9 of the essential amino acids that your body cannot manufacture on its own. You have to get them from your diet, and soy provides all of them in one package.
Okay, so we have energy covered with carbs and fats, and we have the building blocks covered with protein. But now we get to the section of the text that honestly read like a historical medical thriller:
The protectors.
vitamins and minerals.
This is where the tone of the whole science shifts from growth to defense. Because you can have all the energy and all the muscle mass in the world, but if your internal chemistry is slightly off, you just crumble. These micronutrients protect us from catastrophic disease.
And the text uses 2 specific case studies to prove this. And honestly, the first case study is a classic historical horror story.
The Sailor's Curse.
Groovy.
The year is 1746. The protagonist of our story is a Scottish physician named James Lind.
Picture the scene. You are a sailor on a long naval voyage. You haven't seen dry land in months. You're eating nothing but dry, hardtack biscuits and heavily salted pork. And suddenly, your own body starts to revolt against you.
It is a truly terrifying disease to read about. It starts mildly, with just severe lethargy, but then your gums start swelling up, they turn dark, almost black, and become sponge-like. Your teeth literally loosen and fall out of your head. But the scariest part...
It gets worse than your teeth falling out.
Oh yeah. Old wounds like scars from a sword fight you had 20 years ago, they suddenly break open and start bleeding all over again.
Wait, old scars just spontaneously open up. Why on earth does that happen?
Because vitamin C is fundamentally required for the synthesis of collagen. Collagen is essentially the biological glue that holds all your connective tissues together. It provides the structural integrity of your skin, your blood vessels, and your gums.
Okay.
Without vitamin C, your body simply stops making that glue. The maintenance crew goes on strike, so you literally start to unzip at your weakest points, which are old scars.
That is an absolute nightmare. So Lind is on this ship, the HMS Salisbury, and he sees his men dying in agony, and he decides to run an experiment.
Which ended up being one of the first truly controlled clinical trials in medical history. He took 12 sick sailors, divided them into pairs. He gave some of them cider. He gave some of them diluted sulfuric acid, which, yikes, do not try that.
Yeah, that sounds counterproductive.
He gave others vinegar and some seawater. But to 2 lucky sailors, he gave 2 oranges and 1 lemon every day.
And what was the result?
The citrus group recovered almost miraculously. Within just 6 days, they were completely fit for duty while the others were still dying.
All because they got the ascorbic acid, vitamin C.
Exactly. Though, to be fair, they had absolutely no idea what vitamin C was at the time. They didn't know the molecule. They just knew the fruit cured the curse. But it beautifully highlights how a tiny, completely invisible chemical in your food can literally be the difference between life and agonizing death.
Case study number 2 brings us much closer to home, and it is fascinatingly geological. The text talks about the Himalayan region and the northern plains of India in the 1960s.
Right. There was a widespread, terrifying epidemic of goiter.
This is the visible swelling of the neck, right?
Yes. The thyroid gland, which sits in your neck, creates this massive butterfly-shaped swelling. It happens when the thyroid is desperately working overtime, trying to produce essential metabolic hormones, but completely failing.
And why was it failing for all these people in this specific region?
Because it lacked the crucial raw material to make those hormones, iodine. And the scientists investigating this found that the cause was actually in the ground itself.
This completely blows my mind. The dirt didn't have iodine.
Exactly. The Himalayas are highly prone to heavy soil erosion. Over millennia, the iodine gets washed away from the topsoil by relentless rains and melting glaciers. If the dirt lacks iodine, the crops grown in that dirt lack iodine. The drinking water lacks iodine.
So the people eating that local, supposedly healthy food developed a severe, debilitating deficiency.
It is a perfect, somewhat tragic example of how our health is intimately, unavoidably tied to the land. You can eat what looks like a perfectly healthy diet of fresh vegetables and grains, but if the soil is fundamentally impoverished, you're still going to be malnourished.
So what was the public health solution? Because obviously we can't just fix the soil of the entire Himalayan mountain range.
No, geoengineering the Himalayas is impossible. So the government came up with a brilliant intervention. They introduced iodized salt.
Fortification.
Exactly. They realized that absolutely everyone eats salt. Rich, poor, north, south, mountain, valley. So they simply sprayed the common table salt supply with a tiny amount of potassium iodate. It was a massive, sweeping public health victory. It virtually eliminated the goiter epidemic in those regions.
Speaking of salt, there is a sidebar in the text that I found totally mesmerizing. It talks about where this salt actually comes from in the first place.
The Igorians.
Yes, the Igorians tribe. I had zero idea about this community and their process.
It is a phenomenally grueling profession. They work primarily in the Little Rann of Kutch in Gujarat. The text says they work in extreme, punishing desert heat for 8 full months of the year.
And the landscape is surreal. It's described as this vast white desert.
It is. What they do is they pump brine, which is hyper-salty groundwater, from deep under the earth. Then they spread it out in these massive, shallow, square salt pans. And then they just wait. They rely entirely on the brutal sun to evaporate the water.
So they are essentially farming crystals.
That is exactly what they are doing. They are raking these heavy, wet crystals in 40 or 50 degrees Celsius heat. It is a very vivid, sobering reminder that even the most basic, seemingly simple chemical on our dining table, sodium chloride, salt has an intense human story behind it, a story of severe labor in very harsh conditions.
It really makes you look at that little salt shaker differently. It is not just a cheap mineral, it is a hard-won harvest.
It really should change your perspective.
Now, the text provides a really handy chart, a sort of vitamin roll call. I want to run through these quickly because they are so vital, but I really want to focus on the specific mechanism of what happens when they are missing, what breaks down.
Let's do it. It's a good checklist.
Vitamin A.
Vital for your vision. Specifically, it is used to produce a protein pigment in your retina called rhodopsin. That is the pigment that actually allows your eyes to see in low light conditions.
And without it.
Night blindness.
Yeah.
You literally cannot see when the sun goes down. Your eyes can't adjust. Best sources are orange things like papaya and carrots.
Vitamin B1.
Also known as thiamine. This is critical for your nervous system. A deficiency causes a disease called beriberi, which severely affects the heart and the circulatory system. In extreme cases, it actually causes nerve damage and paralysis. You get this primarily from liver and legumes.
Vitamin D. Now, this one is unique because we don't just eat it.
The sunshine vitamin. Your skin actually synthesizes it from cholesterol when it is struck by UVB radiation from the sun. It acts more like a hormone than a traditional vitamin. It physically tells your intestines to absorb calcium from your food.
So without vitamin D, you could eat all the calcium you want and it wouldn't matter.
Exactly, it would just pass right through you. And without it, children get rickets, which results in soft, painfully bent and bowed bones.
And calcium itself.
The structural mineral. It's the concrete for your bones and teeth. Without adequate calcium, they decay, they become porous, and they break easily.
And finally, iron.
Pure blood health. Iron is the literal central atom inside the hemoglobin molecule in your red blood cells. It acts as the magnet that grabs onto oxygen in your lungs and carries it around.
So if you have low iron,
You get anemia. Your blood literally cannot physically carry enough oxygen to your brain and your muscles. You feel constantly weak, chronically tired, and breathless after minor exertion.
so you really need your green leafy vegetables and your beetroot.
Absolutely.
Yeah.
Popeye was right. Spinach is your best friend here.
It is like a chemical checklist for staying alive. If you miss even one tiny item, a very specific critical system in your body, it just starts to glitch and fail.
It is. The human body is an incredibly complex machine, and these vitamins and minerals are the spark plugs and the lubricants that keep the engine from seizing up.
But then right after this, there's a component of food mentioned that provides absolutely nothing. Zero nutrients. Zero energy.
Ah, yes. The unsung hero of the digestive tract.
Roughage. Dietary fiber.
It seems totally counterintuitive, doesn't it? Why on earth would we need to eat something that the body cannot digest, do not absorb, and get 0 calories from?
Yeah, the text is very clear that it provides no nutrients whatsoever, so why even bother?
Because it is all about the mechanics of the system. Think of your digestive tract as a very long, muscular tube. If you only ever put soft, highly processed, fully digestible food in there, things get sluggish. Things get stuck. Fiber adds necessary physical bulk.
What does that bulk do?
It absorbs water as it travels, and it swells up.
Kind of like a sponge.
Exactly like a sponge. Or better yet, think of it as a broom. As it moves through the intestines, it physically stretches the walls, which triggers a process called peristalsis.
Peristalsis.
It's the rhythmic, wave-like muscular contractions of the gut. The fiber basically sweeps the waste along and forces it out. It's the ultimate preventative for constipation.
So it is essentially the logistics and transport manager of the human gut.
That is a phenomenal title for it. Plus, we now know, though, our specific source text doesn't go too deep into this newer science, that while we can't digest fiber, our gut microbiome can. The good bacteria in your colon absolutely feasting it up.
What are the best sources to get that broom working?
Whole grains, pulses, and fresh, unpeeled fruits. Basically, plant foods in their most natural, unaltered state. If you diligently peel the skin off an apple before you eat it, you are literally throwing the best fiber right into the trash.
And the final essential component mentioned in this section is water.
The fundamental medium of life. We are mostly made of water. It is the universal solvent that dissolves all these vitamins and sugars so your cells can actually drink them in. It transports the waste products to the kidneys for filtering, and it perfectly regulates your core temperature through the evaporation of sweat. You can survive for weeks without any food, but only a few days without water.
Okay, so we have all our raw ingredients. We have our macros, our micros, our fiber. Now, the text takes us back into the kitchen to actually cook, but it presents a real dilemma here.
The cooking versus nutrition conflict, it's a constant battle.
Exactly. We cook food to make it palatable, to soften it, and, as you mentioned earlier, with fermentation to kill harmful bacteria. But the text explicitly warns us cooking can be